About scatter plots in particular. Scatter plots are used to look for relationships between two related sets of data. So, for example, your shoe size and your height. In this particular case, you've been given the instructions. Mr. Atkins teaches current events course and is known for making his final exam, very tough. And what Mr. Atkins is looking for is a correlation. He wants to know if there's a relationship between the amount of hours someone studies and the score they get on his exam. And so he records for each person those two pieces of data: how many hours they studied, probably asked for on a survey, and then their final score on the exam. Okay. So for the purposes of our example here, I have created a set of data of my own. This is not the data you've been given to graph. So you still need to do the data that you've been given in the assignment. Okay? So basically what this means is person 1 studied 2 hours and had a final score of 53. Another person partway down studied 13 hours and got a score of 78, and so on and so forth. Okay, so here's what we're going to do with this data. Probably should have, for my example, reduced the number of data points, but it'll work. Okay, so what I'm going to do is I'm going to plot each piece of data, each row. So 2, 53. Now note the scale. You have some decisions to make as far as the scale you make your graph. I made 1 hour increments across the bottom, 4 hours. And if you look at my scale, every 4 tick marks is 10 points of score. So that means 95, for example, is halfway between, and each of these represents 2.5 points. Okay. So the first data point, 2 and 53. I'm going to go 2 to 52.5, 53, right about there. 0, 38. Oh, I just realized I didn't do the scale right because I went down as far as 38. Okay, so let's adjust my scale. So I'm going to make further adjustments, which you may find yourself having to do as you do this assignment here. So it looks like the lowest score is 38, so I got to go as low as 38. Okay, so let's go down to 35. No, let's go down to 30. Okay, and let's go every other one. So 40, 50, 60, 70, 80. So every other one is 10, 90, 100. Okay, and that'll work. You may find yourself adjusting scales, and that's fairly common. Okay, so 2 and 53. So 2 and 55, 53 is about here. 0 and 38, right about here. 2 and 58, 2 and 58. 5 and 70, 70. 4 and 63. 8 and 65. 6 and 68. 4 and 72. 8 and 73. 6 and 75. 10 and 92. 92. 13 and 78. Okay. Where were we? 12 and 83. Okay, 13 and 90. 14 and 88. Oh, I have another error on my scale. I skipped 14. So let's fix that. So 12, 14, 16, 18, 20. There we go. Okay, the last one I entered was 13 and 90, 12 and 83. I already entered that. 13 and 90, and there we are, 13 and 90. 14 and 88. Boom, boom, boom. 11 and 78. Now notice that's the second 78. So what I tend to do when that happens is I circle it. So I know that that data point occurs twice. So 11 and 78 and 16 and 90. And 16 and 95. 20 and 88. And 15 and 100. Okay. Now the questionnaire, the worksheet you have asks a couple of questions. So let's kind of talk about it. So make a scatter plot. We did that. Does the data have positive correlation, negative correlation, or no correlation? So if it's going up to the right as opposed to down to the right, since it's going up to the right, we say this has positive correlation. If it wasn't going up and wasn't going down, that is, if it was flat or just nebulous, we'd say it has no correlation. Okay? And now part 3 says, without the use of technology, in other words, you can't use a regression program like Desmos or Excel to calculate your regression line. You have to find your regression line by hand. So what you do is you take a ruler or you rake a tooler, take a ruler. I kind of estimate what the slope appears to be like, kind of taking into account. You can kind of blur, squint your eyes and blur at it a little bit. Okay, and kind of make it so that it has the right slope and that it goes right down through the middle of the data, that there's an equal number of dots above and an equal number of dots below. Okay, and we'll use that for our line of best fit, we call it. A regression line is something a little more specific. It's calculated using something called the method of least squares. There's a formula for that. But we're just doing a line of best fit, which is a regression is a type of. Okay, so now we've got to write the equation of the line. So here we go. Let's take note on a couple of places, a couple of points. We just need 2 points on the line in order to write the equation of the line. And the easiest way to do it is to note first what the y-intercept is. Y-intercept of my line seems to be 50. Okay? And it would help if I could find another grid point. A grid point is a place where the line intersects a horizontal and a vertical line on your graph. On this one here, I seem to have a grid point, and the further out you go, right here. Right here. Okay, so that's a grid point. That's not a point in my original data. It's a point that's on my line. And so I'm going to take note of what this coordinate is. It seems to be 22. And it seems to correspond with a score of 115 if I were to extend that scale. Now, obviously, we don't have any scores of 115. This does not represent any data in the original data, any point in the original data, but it's just going to be used for me to calculate the line of best fit. Okay, and so my next task is to calculate the rise and the run. The rise and the run. Now there are formulas you can use. You can use something called the point slope formula. That's possible. You can use the slope intercept formula. That's what we're going to use. For the slope intercept formula, we need the slope. Okay? So just remember, I'm counting by 5. So 5, 10, 15, 20, 25, 30, 35, 40, 45, 50, 55, 60, 65 is the rise, or we can take the low score 50 and the high score 115 and subtract and get 65. Okay, over here we're counting counting by whole numbers, so 2, 4, 6, 8, 10, 12, 14, 16, 18, 20, 22, or I could just have pulled the number from there, 22. So the slope is rise over run. I'm going to put that in here. Rise over run, 65 over 22. Okay. Now we can leave it like this. We can try to reduce it. It doesn't. Okay. Or we can give a decimal approximation, because this is all, after all, an approximation anyway. Okay, I'm going to bring up Desmos here. Desmos, not des least. Okay. And that's just my calculator here. And I want to do 65 divided by 22. And I get 2.95, right? By the way, if you click on this, it'll reduce the fraction for you, but there's no reduction. 65 over 22 doesn't reduce. Okay, so 2.95, or actually, for the sake of rounding, this is actually 3.0, right? So approximately 3.0 to the nearest tenth. So it has a slope of 3. So here's what this tells me, and this is really kind of cool about slope in correlation. It tells me for every 1 hour of study, I get a typical increase in my score on my test of 3 points. So I can think of it that way. I can think of it, if I study 1 more hour, I'll gain 3 more points on my test. If I studied 2 hours, I might gain 6 points on my test, and so on, because that's the rate of change of score over hours studied. So that's kind of what the interpretation of that is. Now let's write the equation. You may recall the formula for the equation of a line is y equals mx plus b, where m is slope and b is the y-intercept. I also like to call the slope the rate, points per hour, and the y-intercept is the start value. If you don't study at all, you can expect a score of about 50. Okay? And so let's write the equation. Y equals 3.0x plus 50. Okay? And so this is the equation of my line of best fit. All right, so now part 4, we're to use this prediction, this equation, to predict the score for 2 people who studied for 15 hours and 9 hours. Okay? So what that amounts to is this. You're going to let x be 9. In that case, y equals 3.0 times 9 plus 50. 3 times 9 is 27. 27 plus 50 is 77. So someone who studies 9 hours can expect to get a score of about 77, plus or minus some, because this is an approximation. If I let x equal 15, then y equals 3.0 times 15 plus 50. 3 times 15 is 45, and 50 is 95. So a student that studies 15 hours can expect to get a score of about 95. Okay? Now it says compile the results of parts 1 through 4, put them in a Word document. I'm okay, actually. You don't have to do this in a Word document. If you want to do this on paper like I've done, you can simply take a picture of your work. I'm doing this, by the way, in an Autodesk sketchbook. If you want to use that, you can. Just turn in a graphic file that has all of this. Okay, so you need part 1, you need the scatter plot. Part 2, you need to answer the question, is it a positive correlation, negative correlation, or no correlation? Part 3, you need to draw the line of best fit and write the equation of it. Part 4, you're going to use the equation to predict the score for someone who studies for 9 hours and someone who studies for 15 hours. Okay? So hopefully that answers all your questions.